In this video, I'm going to show you the mechanism for hydrohalogenation for the reaction of alkenes. Now, as you can see, we have, as example here, we have propene that react with hydrochloric acid. Our product should be this. We're going to get this as your product. Now, let's see how the mechanism goes for this. As you can see, the first step is the formation of carbocation. Okay, so we have here hydrochloric acid. So what will actually happen? At first, this bond is going to undergo heterolytic cleavage, where both of the electron will be given to chlorine. In this process, chloride ion will be formed. And our H here is actually becoming hydrogen ion. Now, since it become hydrogen ion, and this side is nucleophile, which is something, nucleophile is a species which having rich electron. So what will happen? Okay, what will happen? This double bond or the nucleophilic side will attack the H+. Will attack the H+ to produce this. So you have to determine, since H is added here, so you have to determine at which side it will go. Is it C1 or C2? So as we know, according to Markonikov rules, H will go to the carbon with more H, and therefore hydrogen will go here. Hydrogen will go here. And as you can see now, our carbon is having 1, 2, and 3 electrons surround it. Okay, and this makes this electron become positive as it has less 1 electron. So this is our carbocation, and specifically this is secondary carbocation. Now, before we proceed with second step, I would like to show you just now that this H is actually become H+. H+ is electrophile. So, in the first step, as you can see, electrophile is added to the alkene, and that is why we call this reaction electrophilic addition, where the first species that been added to the first species that had been added to the double bond is electrophilic, and that is why we call it electrophilic addition. So let's proceed to the step 2, which is the nucleophile attack. So bring here back. So we have our carbocation here. And we also have our Cl. Now let's write the Cl with something red. Okay, so what is going to happen is that this Cl, because it is full of electron, will attack the positive side to produce this. And there you go. This is the mechanism for hydrohalogenations of alkene. So let's try this. You may pause first and do first, and then you can continue looking at this video. Okay, so for this one, we are going to get okay, so how does this happen? All right, let's see. Now, rewrite back this one. Okay, so like we know again, this bond will undergo heterolytic cleavage, and both of the electron will be given to chlorine to produce Cl minus. H become H plus, and thus this double bond side will attack it, and it will produce CH3. Oops, sorry. So this side will become positive. Now, if we classify this is secondary carbocation. Like I always advise you in previous video and in my teaching, whenever you get carbocation, you have to stop first and look if you can make any rearrangement. So if we look carefully, we have this one, carbon 1 and carbon 2. We can actually make the rearrangement by undergoing the 1,2 hydride shift. But with which carbon? Is it carbon 1 or 2? Yes, the answer is carbon number 1. So we make what we call as 1,2 hydride shift, and we are going to get this structure. Okay, so the shiftings happen, the rearrangement happen, and now for the final one, with the chloride ion will attack the positive side. So it attack here, and we are going to get this. Ta-da! There you go. So do not forget to watch the next video, which is the mechanism of hydration of alkene.